Hi, my name is Jin Yiding, and I'm a product manager of AWS Database Migration Service. Welcome to another video of this series of videos on building S3 data lake using AWS DMS. In the last video, Suvendu discussed how to configure DMS in a detailed demonstration. In this video, we will go through the DMS best practices. Let's get started.
As we dive deeper to discuss using DMS to build data lakes, we want to talk about the best practices to set up configuration parameters and optimize DMS tasks to better ingest data into S3 data lakes. In this video, we are going to cover the following agenda items. We will start with choosing the right replication instance type. Then, we will talk about S3 file formats. What are the supported data formats and how to configure them for data lake building? Then, we will talk about CDC Transaction Order. How does that help with data lake building and what are the different options available? Then, we will talk about date-based folder. This is a very useful way to optimize the output files generated by CDC so that they can be consumed by downstream applications. We will follow by data transformation, as in how can we transform the data before it goes into S3, and what are the common transformations we have seen customers using to build data lakes. The final agenda item is S3 target data validations. How can we validate the data in the data lake against the source to make sure that they are consistent? At the time of this video, DMS data validation does not support S3 as a target. We are going to share a typical approach on how to validate data between sources and S3 target. It is important to choose the right replication instance class for any DMS tasks. AWS DMS currently supports the T2, T3, C4, C5, R4, and R5 Amazon EC2 instance classes. You should use T2 and T3 instance classes for development and testing workload, but avoid them for production workload. C4 and C5 instance classes are compute intensive and are good choices for heterogeneous migrations and replications. R4 and R5 instance classes are memory optimized and are suitable for heavy workloads with high throughputs. Now let's talk about how does DMS work with S3 target in general. When DMS runs for the first time, it will create an initial bulk dump file of all records in the database with the format shown in the slide as full load files, which will have a specified bucket name, schema name, and then table name. By default, all full load files will be in the CSV format. There are other file formats available like Parquet, which we'll discuss in next slide. Once full load is complete, DMS will start generating CDC files for the table, which has a similar schema with the addition of the type of operation performed. I is for insert, U for update, and D for delete. It's a common pattern to have one job running that performs the bulk plus CDC operation, and another that does a less frequent bulk dump each time as a way to create checkpoints and resynchronize the data if something goes wrong with downstream processing. Let's now talk about S3 file formats. The default file format is CSV. However, this is a configurable behavior controlled by extra connection attributes. Extra connection attributes, or ECA, are settings specific to source and target endpoints to help customers customize how DMS interacts with their endpoints. Every single source and target endpoints has its own ECA, with details can be found in the DMS public documentation. For data lake use cases, the most commonly recommended file format is Parquet, since it's a columnar format best optimized for storage and data processing. Parquet has the ability to store file schema as well as the option to store column-level statistics like minimum, maximum, count of nulls, and distinct values. Another benefit of using Parquet format is its ability to have higher compression ratio as compared to CSV format. In order to set this data format for DMS, you can set that in target endpoint using ECA data format and set the value to Parquet. There are other ECAs relevant to S3 file formats as well. For example, ECA dict page size limit sets the maximum allowed size in bytes for a dictionary page in a Parquet file. If a dictionary page exceeds this value, that page uses plain encoding. ECA enabled statistics enables statistics about the Parquet file pages and row groups. This allows column-level statistics to be stored as metadata with Parquet files. This is particularly helpful when you use Spark for data processing due to optimizations such as predicate pushdown. The last ECA is Parquet timestamp in millisecond. By default, DMS uses microseconds for precision. By using this parameter, DMS write timestamp in milliseconds, and that's what AWS Glue and Amazon Athena can handle. Otherwise, it will cause potential data issues. Now let's look into CDC Transaction Order. By default, new CDC data for each table is stored in the prefix of that table. What I mean by that is as new data comes in for the table, data will be stored in your S3 bucket /schema name /table name. However, many times when building data lakes, there are downstream ETL processes which need to have a point-in-time view of tables and preserve the order of transactions as they happen on source databases. Within DMS, you can set ECA preserve transactions to true, and then DMS will start to record transactions from all tables together in such an order as they happen on source databases. One limitation is that the changes are only supported in CSV format. Next-level ETL job will have to consume this data and create a merged version of downstream tables to build a point-in-time view of source tables. As we just learned, all new CDC data will be stored in the table-level prefix. Let's say you have a use case where you want to preserve transaction orders. Then all data of each individual table will be stored in a single prefix, which is bucket name /schema name /table name. There will be no partitions at the table level. For accessing tables with huge data volume, this will cause performance challenges since ETL jobs will have to process or scan all data at once. A better approach is to partition data, and it's usually based on transaction commit date. Using date-based folder partitioning, you can write data from a single source table to a time hierarchy folder structure in an S3 bucket. By partitioning folders, you can better manage your S3 objects and limit the size of each S3 folder. In order to configure this, you enable ECA date partition enabled and date partition sequence as shown in the slide. Let's continue on with data transformations. With DMS, you can use operations and transformations to enhance the data as part of the replication process. For example, there is an inconsistency between CDC files and full load files, as CDC files has an additional column for operation code I, U, and D. To make both files consistent, you can add an additional column, operation code with value I, in front of all full load rows. This will make it easier for downstream ETL jobs. With data transformation, you can filter your data selection to only load new data into S3 target. You can use expressions to flag records on target tables as inserted, updated, or deleted at the source. You can also rename a column or add a new column with default values as part of the data ingestion. Data transformation brings more flexibility in data processing to make downstream processing easier. Lastly, let's talk about data validation. As part of any replication, it is important to validate or compare the data between source and target. At the time of this video, DMS has the option to validate data between relational databases, but not with S3 as a target. To validate your S3 target data yourself, one approach is to perform some ETL or use something like Apache Hudi tables to create a merge table using CDC incremental files. This table will be brought available in Glue Catalog. From there, data in S3 can be accessed via Athena, and you can use Athena Federated Query to join source data with S3 data and perform validation. There are other customized ways to validate S3 data, but this architecture is very commonly used. Thank you very much for watching. In this video, we learned about best practices using DMS to build data lakes. In the next video, Suvendu will talk about the best practices specific to S3. We'll see you in the next video.